So now let's understand how a UVL is converted to a point load. So let's consider a simple example for this. Now here we have the first type of UVL which has an intensity of 12. See, the longest arrow is of the intensity 12 kilonewton per meter. Always the given value will be the longest one or the highest one. Okay. So uniformly it goes on varying or changing up to this point where it becomes 0. So now we have a triangular UVL of intensity 12 and span I have kept as 6 only. So magnitude of this UVL as a concentrated force is obtained as half into base into height, and this concentrated force acts at the CG of the triangle, that is 1/3 from the base, okay, 1/3 from this side or 2/3 from the apex. So if you consider this as the base of the triangle, okay, 1/3 from the vertical side or 2/3 from the apex or the tip, this force will act. So how we calculate the intensity of this force? We go and we calculate it as half base into height, which is nothing but the area of the triangle. Okay, half base is your width 6 meters and height is the intensity 12 meters. Okay, sorry, 12 kilonewton per meter. So you calculate the intensity of the UVL to find an equivalent point load as half into base into height, considering this as a triangle. So half base is your 6 meters and height is 12 meters. Okay, 12 kilonewton per meter. Then where it will act? It will act at the CG. Now you know how to locate the CG of the triangle. 1/3 from the vertical side. Please excuse me, I have written here base. It should be the adjacent or the vertical side. Please excuse me for this word here, base. It will be 1/3 from the vertical side or 2/3 from the tip. Okay. So it goes on the principle of CG of the triangle, for which we have already derived the equation and we have solved a number of examples in centroid topic also. So how we convert a triangular load to an equivalent point load? We convert a triangular load to an equivalent point load by using the formula half into base into height, okay, where base is nothing but the length of the triangle and height is nothing but the intensity of the given UVL. So in this case, if we apply that principle, we get half into 6 into 12, which comes out to be 36 kilonewton. Now when we convert it to a point load, unit becomes kilonewton. When it is a UVL, the unit is kilonewton per meter. Take that important point into consideration. So it acts at 1/3 from the vertical side or 2/3 from the right side support. Okay, so 1/3 from the vertical side means 1/3 of 6 is nothing but 2 and 2/3 of 6 is nothing but 4. So a single point load will act at 2 meters from left support, 4 meters from right support when we convert it to an equivalent point load. Now this picture will make you the concept, will make the concept more clear in this, right. So we have a UVL triangular shape, 12 is the given intensity and 6 meter is the length. So its equivalent is how much? 36. And वो कहाँ act होगा? At the CG of this triangle. कहाँ पर है CG? 1/3 from the left side, that is 1/3 of 6 is 2 and 2/3 from the right side, that is 2/3 of 6 is 4. So this both are equal. So when we have to do analysis, if you get this similar figure or UVL, you have to convert it first into point load and then consider it for analysis. This goes easy. So the last part of your loading, let us try and understand with the example, which is a UVL, but it is trapezoidal in shape. Okay. So now this we can break into two parts. Now see here friends, we have this highest intensity as 12 kilonewton per meter, and here right side it is not becoming 0, it is how much? 2 kilonewton. That means we can break this entire figure into two parts. One is a UDL and one is a triangular UVL. Now carefully look at the figure how I have broken it. Okay, from this 2 meter I have drawn here a straight line. Okay, out of this 12 I have taken this height 2 and drawn a straight line. Okay, so I get an UDL of 2 kilonewton. Now यहाँ पे ऐसा line आएगा एक. Okay, means I have cut this 12, नीचे का 2 meters निकाल दिया है. So I will get that UDL. Then remaining above, because as I have drawn a line here, when we consider the top, it is remaining as UVL, which is in triangular form. And now this is 10. Why is this 10? Because out of 12 I have removed of 2. Okay, I have removed 2 as UDL and remaining 10 I have kept as UVL. So now this pictorial this explanation should be sufficient for your understanding, because all of you have done your lab also. Your views are hopefully good, and this much of basic common sense and understanding at your level you should have in engineering. Okay, so now this figure, what I have done is, it's trapezoidal in shape. I cannot directly analyze it, so I am making it into two parts. The bottom part, okay, the bottom part of 2 kilonewton per meter intensity acts as a UDL, whereas the above part 12 minus 2 is remaining is 10, acts as an UVL of triangular shape, for which we have done the analysis. So how will we convert this into an equivalent point load? It is simple. Apply the principle for UDL separately, apply the principles for UVL separately. So on a single beam you will have 2 point loads when we convert this type of UVL. Okay, one point load will represent the UDL, other point load will represent the UVL in triangular shape. So let us see that how it is. Equivalent concentrated forces. Right, we have broken the given trapezoidal UVL into two parts. One is a UDL, other is the UVL of triangular shape. Now for this we have studied how we take the intensity half, okay, how we take the intensity, span into intensity into span by 2, that is 6 into 2 into 6 by 2. Okay, so we get the answer as 36, right? We get the answer as 36. 6 into 2 is 12, 12 multiplied by 3. Where it will act? At the center, because this is UDL. In case of UDL, it's a rectangular shape. So for rectangle, where will be the CG? Half of the span. Okay, so 36 kilonewton will represent 2 kilonewton per meter UDL, which acts at the center of the beam. Now let us come to the triangular part. Triangular part has an intensity of 10. How we convert it into equivalent point load? Half base into height, that is nothing but the area of the triangle. So half into base is 6 and into height is 10. Okay, so 10 6 are 60, 60 ka half hai 30. Okay, so 30 kilonewton is a point load which is equivalent to this UVL of triangular shape, and where it acts? 1/3 from the vertical side and 2/3 from the tip, that is 2 meters and 4 meters. So finally what diagram we have to use for analysis? Total representation is here. Okay, this figure, this 30 is the UVL triangular shape, this 36 is the UDL, okay, which is rectangle shape. So one UVL of trapezoidal cross section can be represented as 2 point loads as shown in this figure. Now along with this, many times in the examples of the beam we can get a moment also. Now you know how to use the moment. If it is a clockwise, if it is running clockwise it is positive, if it is anti-clockwise it will be negative. So these three types of loads along with the moment you will find in the beam analysis examples, which will be covered in the next lecture. So in today's lectures we have tried to understand what are the types of loads which are acting on the beams. We have studied three types of loads. One is the point load or the concentrated load, second is the UDL, and third is the UVL. In UVL we had two types, one is a triangular shape, other is an trapezoidal shape. So trapezoidal shape we broke into two parts, one rectangle and one triangle, and tried to learn how to analyze it. Hopefully this part of the lecture is clear to you all. Go through this. You yourself can pick up any number, okay, give it and try to work out these examples. What I mean is, now if you want to study this example and find the equivalent load as a homework, take this value here as 30, take this length here as 8 and work out the equivalent point loads. Next you take this value as say 22, they take this length as say 8.5 or 6.5, anything what you assume, work out the equivalent point loads. So as assignment for UDL, UVL both types, 3 at least workouts you do and send it to me, so that while solving the examples it will be easy. So see you in the next class with the problems on beams. Thank you.